So my name is Daniel. I'm from Site 24/7, Manage Engine Site 24/7 from Zoho Corp. So today I'm going to talk about navigating the complexity of distributed microservices. So here microservices are complex, right? And distributed microservices are even more complex. So this image, right, if you see, we have multiple technologies. These are all bits and pieces of microservices. So to the bottom right here, I have the Kubernetes, and then here we have the monitoring, here we have the SQL service, here we have the authentication service, right? So this is a simple representation of how the microservices are connected. And to begin my presentation, I just wanted to talk about digital transformation, what it's all about, why we are all here, right? Why we are all gathered here is because of this digital transformation that is happening. For me, what digital transformation is, like, let's say, for example, 15 years back, when I wanted to open a savings account, I have to go to a bank, fill in the form manually, and then have to submit it, and they will find some corrections. So I have to go 2-3 iterations, and then after I submit, come back after a month, the account is open, here is your passbook, and then the next month, come get your debit card, right? But now we have promises made by bank where account opening is done in 5 minutes, right? There is a ad where savings account can be opened within 5 minutes time. And how this is possible, right? It's because of the digital transformation that is happening, the adoption to digital technologies. So there are APIs. Say I want to open an account. So the banking service can easily authenticate my Aadhaar or PAN card with the PAN services using an API, and that way they promise the bank account opening in 5 minutes. So that's digital transformation for me, how I've experienced a bank account opening and now what is there. And we see a rise in this digital transformation post this COVID era, because today's generation, right, they are born digital. My son, who is 4 years old, right, when he launches some video on the TV and if he sees the buffering icon, right, he gets irritated. He just wanted to change something. He thinks that it's not working. But I think when I was a kid, or when I started using internet, we used to load a video, wait for it to completely load, and then we start viewing it, right? But today, the generation, right, they are born digital, and they launch an app. They want that app to work seamlessly, right? They want the app to be cool, and we are all here to do that. We are all here to develop those kind of apps, provide seamless experience to the users. When a user accesses our application, it has to work seamlessly, right? There should not be any delays. There should not be any performance issues, because we see half a second time, right? If they see a page loading, because as we are in the observability monitoring field, based on the survey, the data we collect, we understood that half a second is the time limit where users' patience level are. That's what the industry standard for measuring user satisfaction level, half a second. And let's take the simple e-commerce transaction where a user logs into a product, searches for a specific item, adds it to the shopping cart, the payment gateway, and then completes the purchase process. This seems to be a simple transaction for us. And here, each and every step is a microservice today, right? Login, that's a separate microservice where we have our IAM services, authorizations, authentications, and then product search, searching for the product catalog, and we have the shopping cart, wish list, and then the payment gateway, we connect with third-party payment gateway providers, and then the logout provider. So each and every component can be run as separate microservices. And when I say separate microservices, so this is a simple example of a modern app stack, right? This is for one microservices. So here, things that you see in the pink, right? So these are all the different layers. So we have the application layer, infrastructure layer, network layer, the database layer, and each layer has 4 to 7 components. Let's say, for example, network services, right? So we have the API gateways, we have the load balancers, CDN servers, DNS servers, right? And each component, there are 4 to 5 products. And if I go into a specific cloud service provider, it's different, right? So this is one microservices that is part of a distributed application. And when I say distributed application, right, so I've taken this 25 as an example. It might be less or it might be more, right? So if you see, all these microservices has to talk to each other to provide a seamless experience for the end user. And here, this is a sequence where it's not visible, I'm sorry, but here it's again the same shopping cart sequence, right? I have elaborated. So here we have the authorization layer where the user management is there. So we have the authentication authorizations, and then here we have the product catalog where we have the products listed out. And as each and every microservice are separate, we can have separate deployments. Let's say I can understand that my product catalog is not good, right? That's not driving people into the business, right? What I can do is I can have a separate deployment for my product catalog alone without disturbing my entire purchase flow, without disturbing my pricing structure, without disturbing my login structure, right? So that is the power of microservices. So I can have 25 different releases. And the important thing is that I have to make sure that all these things work together seamlessly. So API calls are made instead of direct functional calls. And this also empowers enterprises adopt to this digital transformation. Let's say fintech industry, right? Still people use traditional applications, but still they want to move or offer services to customers digitally. They want to have mobile banking, but back in they will have their old technologies, applications running, like the mainframes, right? So to adapt to that, they can opt for these kind of microservices. So they can simply use API calls to have the applications communicate between each other and provide the experience to the users, application experience. And the problem starts when something breaks, right? So everything works fine, no one is worried. If there is some problem, let's say for example here, if the payment gateway is down, so we are going to lose business. That's when we feel the heat. And who finds the issue first is very important, whether it's going to be the users. What happens if a user finds that there is an issue? So we lose our reliability, right? And then we lose business there. That's very important. We lose business. The customer is not going to come back again. And what if the DevOps or the SREs finds the issue first? So when we find the issues as DevOps and SREs, we need to understand when the issue happened, what is broken, and why that issue happened. That's very important. That's when we can fix issues and we can prevent the same issue from happening again. And for that, you need to understand in which layer the application had an issue. Whether at the application layer, is there any application latency, or there are any timeout errors, or is it at the database layer where, example, we have some slow query executions, and then we have a server layer if it's a server's performance, the CPU or memory issues, and then network layer where we see some network congestion, bandwidth consumptions there, or at the storage layer, inadequate storage, right? So you need to understand in which layer the problem is, and we can address that issue. And with this distributed microservices, think on how we can identify where the problem is, understanding the root cause of an issue. Because it becomes more complex and applications talking to each other, but teams will not talk to each other, right? When there is an issue, there will always be the blame game, right? When an application goes down, simply put the blame on the network team. Let them take the blame. My application is not working because the network is not performing well, right? So this happens every time. So to solve that, we need a solution which can give you that end-to-end visibility. And monitoring this distributed microservices is more complex. So this is one example that I have taken, monitoring in the sense like collecting telemetry data from each and every layer. So here if we see the application telemetry where it involves APM, API monitoring, the user metrics, browser metrics, and then we have storage telemetry for your storage devices, and then cloud and virtualization telemetry for your cloud services, your VMware. And this is for one simple microservices, this much amount of telemetry data is getting generated. And when I say telemetry, it involves all the data like CPU, memory, disk utilization. When it comes to network, the network in out, bandwidth consumption, right? And then application, you need the number of transaction process, number of errors, exceptions that are reported in the application. So all these telemetry data for one microservices will have no value if they are not correlated, if they are not put together in one single piece. And if I take the network service alone, we talked about different telemetry data, right? But here, this is the telemetry data for one single component, which is network, right? So here we can see we have the API metrics, and then we have the API logs, and then we have the traces. And the same way, we have the load balancer. For the load balancer, we have specific metrics. We have the logs of the load balancer, the traces for the load balancer, right? So the amount of data that is getting generated will lead us nowhere when we want to troubleshoot or identify some issues. So, and this is one layer of one microservice, okay? And we have all the layers like the logs, metrics, traces, the events that are getting generated, the alerts that you receive, right? So one simple incident, right? It might have 100 events. That's the cause of that specific issue. So 100 events, how do I pinpoint to that one specific issue that is causing these 100 events, right? So all these has to be considered. So that's what it calls for unified observability. So you need to observe everything in your application stack, starting from the end user layer where users interact with your application. And today, the way data is getting consumed has varied a lot. People use smartphones, from computers, smartphones, and now we have watches where my data is getting consumed. And we also have glasses, right? Apple glasses. So that's how the data is getting consumed. So we need to understand, and any device the user uses, their expectation is that the application has to work seamlessly. Whether it's a watch, a mobile phone, or a computer, if I access the application, I should have seamless experience. And then we have the application layer, your application, Java, .NET, Ruby. So if there are any errors, exceptions, you need to get the traces of it. You need to give your developers information on where exactly the problem is. The database layer, your SQL servers, application servers, Tomcat. So you need to monitor the performance of that as well. And then the host where you run your applications. And then the network layer, you need to get the net flow, network configuration, right? So observing all these layers will give you the visibility, and you will be able to identify a root cause of an issue, where exactly the problem occurs, in which layer the problem is. So enabling or observing each and every layer is very important. And data-driven decision making needs a context, right? When there is an issue, who will be impacted? What is an extent of an impact? What is the cost involved, right? So here we have who will be impacted, whether it's external customers, internal users, or is it going to be partners? Because all this will have an impact on the business. End of the day, or telemetry data, the technology data, right? It has to sync with the business data, business metrics, right? So that is important. That's how today's enterprises are proceeding. They want their business metrics to correlate with the technology data, technology telemetry. And then we have what is the context of the impact? Is it a single application, or it's a business critical application that is down, right? And then what is the cost of a downtime? Am I losing the sales here, and I'm replacing parts, right? So that every outage has a cost involved. What is the cost? And what is the business impact of this outage, right? So all these needs to be within the context. So one single outage, you have to identify that with the context so that you can deliver business values. And you have to connect the dots between the technology and the business, because that's very important in today's world, right? So each factor has to be understood from an observability platform, because there are certain business KPIs where we have the revenue, the profit. For example, as a pre-sales manager, when I go into the office, the numbers that I want to look is the number of signups, because from the signups, I can build my funnel, right? How many leads that I receive, how many people I can convert. That's my data. That's what I want to know. But if my application, say in the sign-up form, they have made some changes, right? So there are some issues there. There is performance. There is a drop in the number of signups. So that's going to impact my data, my metrics, right? So, but I have no relation with that application, right? So they have their own deployments, releases. But for me, my metrics is important. For me, the number of signups that I receive is important. But a change they make might impact my metrics, right? So that's when we need a correlated visibility, a connected dot between the business and the technology. So for example, here we have business KPIs like the revenue, the profits, the new users that we have acquired. And then we have technology KPIs like the resiliency, the features that we are releasing, how fast we are releasing the features, user experience. And that is dependent on the telemetry data, because we have all the data. The telemetry is where we can identify what are the KPIs needs for the technology. Say, if I understand my user experience is bad, the users are not interacting with the application, the page is slow, so I can have my technology improved. I can opt for new technology. I can improve my technology to deliver better user experience. And that will have a direct impact on my business KPIs. And we need observability even for business related metrics, right? So I have to observe my business metrics. That's what I say. When I go in, I see the number of signups I receive, the number of accounts that we close, the number of accounts we are working in, right? So that's again observing the data, and I relate that data with my application performance. I keep track of what's happening at the application side. If they release any new updates, backend updates, server changes, anything that I'll be knowing of. And observability data will give you the data pipeline, the data analysis, and it will also help you in taking the actions. And AI will help you in connecting these dots. So we have listed a few ways here on how AI can connect the dots between the infrastructure, application, and business. So one is like anomaly detection. So we have seasonal anomalies, because every Sunday evening is not the same as Monday morning 9 o'clock when the market opens, right? So that's when the traffic is going to be more for my application. So we need to have seasonal benchmarking to understand when there is an anomaly reported. So that will help me forecast things. I can easily predict what's going to happen, and I can fix issues. And then we need to forecast or infrastructure compliance. Say for example, disk utilization, right? So when my disk is going to run out of space, is it going to be in 7 days, 10 days, so that I can provision additional disks. I can free up the disk space to provide more space for it. And then NLPs. So we need contextual alarms, right? So for example, as I said, we have 100 events generated. So AI will help us understand those 100 events, summarize the content, and give it in a meaningful way, right? The root cause analysis reports. So the NLP should be there, and AI will help you in understanding things together. We can easily interact with the AI, and you can get the output you want. Like for example, if there is an outage yesterday, I can ask my AI system, what is the root cause of it? It will summarize all the events that happened. It will correlate the events and then give me a single line. So this is the actual cause of an issue, right? And then a small case study before actually I finish my presentation. So this talks about real-time observability. So we saw observability, which is going to help you in addressing the challenges that we face with this microservices world, microservices applications, right? So, and one of our customers took this observability to the next level, where they achieved an interesting use case, right? So this is a multi-brand global automotive company. So they make $10 billion in revenue, and they operate over 40 markets across the globe. And the actual problem they want to solve is with the sales funnel, right? When some users come into their websites, they search for the product, they add it to the cart. So that's when a user comes to their website, that's a sales lead, right? And then after they give in their information, that gets converted as a lead. And then when they make the purchase, they go as a customer, right? And they do not want to lose track of that interaction at any point. So what they did is they used Site 24/7, our product managed engine Site 24/7, and enabled observability in each and every level. So when the user hits the website, right? So they have a unique ID for every user. So based on that ID, they'd be able to track the user's transaction from end to end. From the user visits the web page, we have a real user monitoring which tracks the performance of the website from the user's browser. So they will know that a user has logged into their website. And then the user adds the product to the cart, right? So that is captured from the logs, right? So this is not one specific feature that's solving a problem. So we are going to get the traces, we are going to get the logs, the metrics, everything. In each and every level here, we are going to get different data and we are going to correlate that. And the customer has beautifully synchronized these telemetry data into their CRM, right? When a customer logs onto the page until the purchase happens, everything will be there in the CRM. So if the customer is lost in any one point, they have a CRM flow, an automation there, which is going to proactively get in touch with the customer. So they're not going to lose their business there, right? So this is a very interesting use case that we are still working with the customer. They are still finding gaps in their business that they want to address with our tool. And we are still working with the customer to build them dashboards and address these challenges. So some of the key takeaways is the telemetry data that you collect, right? Do not leave any gap. Each and every point in your application architecture should be made observable. Even you may have unmonitored devices or services. So you have to make them come into the system, right? And then you should always capture and analyze the data within its context. If an application goes down, what is the impact of that outage? Is it only with that specific application, or what are the other services that got impacted? And you have to leverage AI. AI is very critical in today's business. So you have to leverage AI to automate the root cause analysis. You have to think on how we can fix issues when we observe things, when we identify an issue, how that can be addressed, what action that I can take when an issue gets reported, how can I automate that, right? And then we also need to understand the FinOps. FinOps is a new buzzword that's coming out now, because every organization, as they adopt to the cloud, right, the cost incurred by adopting to the cloud services is huge. Because there are several incidents, even for us, right? They come and say our testing team spawned up several instances, and once their testing is done, they leave that instances up and running, and the organization ends up paying for that, right? So you need to keep track of the amount that you are spending on the cloud services also. So you have to understand where you are spending, how much amount you are spending, So that will help you when optimizing your infrastructure for better productivity.